Okay, past paper 2015, paper 2, question 9. Joan is playing golf. She is 150 meters from the center of a circular green. That's the green there, of diameter 30. So the whole thing across there is 30. From there to there is 30. The diagram shows the range of directions in which Joan can hit the ball so that it could land on the green. So it can go that way, that angle. If it goes anything further than there, going to miss the green. So that's logically what the angle is. The diagram shows the range of directions in which Joan can hit the ball so that it could land on the green. Right, find alpha, the measure of the angle of this range of directions. Give your answer in degrees correct to the. So we have to find this angle here, right? So there to there, if we drop a perpendicular down there, we're going to split that angle, right? And they're saying that's 150. So we have a right angle triangle. That is therefore the hypotenuse, because that's the right angle there. Don't think that you're going to put a line in there, because that line may well create a gap there. It may not actually. There may be a slight gap before that goes there, so that's off. That's your right angle there. Therefore, that is the hypotenuse there. Okay, so it's a small thing. Some people might have been inclined to do that. Okay, so we've got to find that angle. Okay, so we have, that's the angle there. That's the half of the angle that we want, right? So we got to go, I'm going to write it out. Sine of alpha divided by 2, right? Half of alpha. That the big one is what we're looking for. We need that because we dropped the perpendicular from there to there. That's 150, which is the hypotenuse. That is the right angle. The hypotenuse is always opposite the right angle, right? And that length there is 15. So it's sine of that angle is opposite over hypotenuse, which is 15 over 150. So the sine of alpha divided by 2 is equal to 15 divided by 50, opposite over hypotenuse, which is equal to a tenth. Sine of alpha divided by 2 is equal to tenth. Alpha divided by 2 is equal to 5.73917, taking the inverse sine of that. And then multiply that by 2, we get alpha is equal to 11.47834. Alpha is equal to 11.5 to 1 decimal place. Okay, so that's there. At the next hole, Joan at T attempts to hit the ball in the direction of the hole H. Her shot is off target. So that's the hole there. That's where they're going to hit the ball from, and they miss, so they go up here, right? The distance from the point where they hit the ball to the actual hole is 385, but it's off. It goes up here, and that's 190. It's off by 18 degrees to the left of that. So her shot is off target, and the ball lands at A, a distance of 190 meters from T. So it's off, and it's 190 meters. That angle in there is 18. TH 385. Find AH, the distance from the ball to the hole correct to the nearest meter. So I'm going to drop a perpendicular there, and then go sine of 18 is opposite over hypotenuse. Then I'll know this angle, or that height there. Okay. Then I want to get the cosine of this and go drop a perpendicular there again. Cosine of adjacent over hypotenuse. So I'll get this distance from there to there. I'm going to show you now in a second. And then this distance here will be 385 minus this distance here. And then so I have this distance, I have this, and then I can use the Pythagoras theorem to get this there, AH, right? So that's the general plan. So okay, so we have all of that there. Now I've dropped a perpendicular from there down to P. I called it P. This whole thing is 385. I need to get this. I need to get this. So I'm going to start off getting the X one. So sine of 18 degrees is equal to opposite over hypotenuse, which is X over 190. So sine of 18 degrees is equal to X over 190. Multiply 190 over 190 by sine of 18 degrees is equal to X. So I know what X is. I'm not going to work out that because I'll get all these little point numbers, etc. So I'll leave it right to the end. You don't have rounding errors and all this type of stuff. You know, as you keep rounding it and rounding it, you'll be slightly off. So it's better to just leave it in that form. It's easier to manipulate as well. So, and then cos of 18 degrees is adjacent over hypotenuse, so it's y over 190. So cos of 18 degrees is equal to y over 190. Multiply that as 190 by cos 18 is equal to y. So I know what this is there. I know this whole thing is 385. Therefore, this thing in here, this pH, is 385 minus this bit, right? So 385 minus 190 by cos of 18 degrees, which is that bit there. I've left them in that form, right? So now we have AH squared is equal to x squared plus this bit squared, which is 385 minus 190 cos of 18 degrees. That's squared, right? So it's AH squared is equal to x squared plus pH squared. That's the pH bit, and that's the x squared. AH squared is equal to x squared. Now x is 190 by sine of 18 degrees, so it's 190 by the sine of 18 degrees squared, plus this bit, which is this bit here, 385 minus 190 by the cos of 18 degrees, 385 minus 190 by the cos of 18 degrees squared, and then AH is the square root of all of this, right? 190 sine of 18 squared plus 385 minus 190 cos of 18 squared. Calculator, you get for 190 by the sine of 18 squared, you get 3447.24325, and 385 minus 190 cos 18 degrees squared is 41738.188. Add them together, you get 45185.431666. Take square root, you get 212.5686. And 213 is the nearest meter. So it's 212.5686, round up to 213 to the nearest, that's 2, so that's 213 meters from there to there. Okay, there. At another hole where the ground is not level, Joan hits the ball from K, showing the ball lands at B. The height of the ball in meters above the horizontal line OB is given by H is equal to minus 6t squared plus 22t plus 8, where t is the time in seconds after the ball is struck and H is the height of the ball. So the ball is struck here, and it follows this parabola to hit point B. And this is the height here. So this is like a quadratic, and that's like t could be an x, and y is the height, so could y is equal to minus 6x squared plus 22x plus, so that's your quadratic equation there, which is a curve, right? It's not a complete, normally the quadratics we have goes down to it starts at 0 or whatever sometimes, so we're cutting it off here. So we're saying it starts at this point here at some height, and it goes, so at time t is equal to 0, this is the start, so time t is equal to 0 is here, and then it takes a certain amount of time to get to there following that arc, right? That's what so we want, and find the height of K above OB, so we want to know what this is, alright? That's the H. So at this point here, that's when everything is starting. T is 0, alright? So if I want the H when t is 0, that'll be 0. That'll be 6t squared, that's 0, and that's 22 by 0, 0. H is going to be 8 at this point. That's going to be 8 there, right? That's pretty straightforward, right? So that's right. So that's the first one. They want to find the height of K above OB, right? So we have, that's the equation, and when time is 0, we have H is equal to minus 6 by 0 squared plus 22 by 0 plus 8. So it's 8. So that's 8 there. Okay. Then it asks for the horizontal speed of the ball over the straight distance OB, okay, is a constant 38 meters per second. Find the angle of elevation of K from B correct to the nearest degree. So the angle of elevation of K from B is, you're at B, from B, and you're looking at K. That's what it means. So we need this angle in here, this very small angle in there, right? That means, now we have this, we just got that as 8, we need OB. But they're telling us that the horizontal speed of the ball over the straight distance, okay, so the equation for this, which you need to know, is time is equal to distance over speed. Everybody knows that, right? So if you're given a speed and you're given a time, you know how long it went, right? So we know it's going at 38 meters per second. How long it took to go the distance, we don't know. We'll have to figure that out. And the distance is what we need to know. If we know what OB is and we have this, then we can get this angle in here. So how long did it take the ball to get from there to there? Right? Well, at t is equal to 0, it's there, right? At that point there, at t is equal to 0, the h is 8, okay? At this point, when it hits here, see this formula here, it tells you after it's in an equation which relates h and time. When the time is 0, you will get your h value here, which is 8. When h is 0, it's here. At h is 0, it's hit the ground. So you will know the time the time it takes to hit that. When h is 0, what is t basically? When h is 0, what is the t? I.e., that's how long it took to go that distance, right? So we can use this equation to find that. So h is equal to minus 6t squared plus 22t plus 8. When h is 0, what is the t? So 0 is equal to minus 6t squared plus 22t plus 8, right? And we'll come back to this one as time is equal to distance over speed. So 0 is equal to minus 6 t squared plus 22t plus 8. And then we get 0 is equal to minus 6t squared plus 22t plus 8. Then bring everything over to the other side just to get rid of this negative minus 6. Minus 6t squared minus 22t minus 8 is equal to 0. Divide across by 2. 3t squared minus 11t minus 4 is equal to 0. A, B, and C. Use the formula. Minus b plus or minus squared b squared minus 4ac over 2a. Minus the b, which is minus 11. B is minus 11. Plus or minus the square root of b squared, which is minus 11 squared, minus 4 into 3, which is a, and c, which is minus 4, over 2a, which is 3, 2 by 3. So 11 plus or minus the square root of 11 squared is 121, 4 by 3 by 4, negative by negative will become positive, you get plus 48 over 2 by 3 is 6. So you get 11 plus or minus the square root of 169 over 6. 121 plus 48 is 169. That's 11 plus or minus 13 over 6. Time is equal to 11 plus 13 over 6, which is equal to 24 over 6, which is equal to 4. Time is equal to 4, or time is equal to 11 minus 13 over 6, which is minus 2 over 6, which is minus 1/3, which is not applicable. This is the one we want, 4 seconds. That says that it takes 4 seconds for h to become, when t is 4, h is 0. That means it took 4 seconds to go from there to there, right? So we know that's 4. We know the speed is 38. Then we can find the distance, which is OB there, right? Once we've got the distance, then we can calculate this angle in here using tan, right? Okay, so we have 4 as it. So time is equal to distance over speed. So we have 8, and we've got time is equal to distance over speeds. So we have 4 is equal to the distance over 38 meters per second. That's how fast it was going. That's what they said. So we can solve for d. So it's d is equal to 4. Might multiply by 38, which is equal to 152 meters. So the ball traveled 152 meters overall, right? In the air, they were talking the straight distance. That's what they said, the straight distance from there to there. Okay, it's relative to a straight. So ultimately, that OB turned out to be 152, and that was 8, right? So now you can calculate the angle. So we've got the tan of theta, which is opposite over adjacent, which is 8 over 152, and then get the inverse tan of that. You get theta is equal to 3.0127 and 3 degrees to the nearest degree. Right. Okay. Then the last bit. At a later hole, Jones' first shot lands at point G on the ground that is sloping downwards. So that's the ground. So it's on a hill. As shown, a vertical tree. There's a tree there. 25 meters high, so that's 25 in total, stands between G and the hole. The distance GC is also 25 in the bottom of the wall, and that's 25 there. The angle of elevation of G to the top of the tree is equal to theta. To that, theta is equal to 1 over 2, or the inverse tan of a half. Okay, and we'll use that in a second. The height of the top of the tree above the horizontal is h, so that's h from there to there, and GD is D. Okay, so we have everything. Write D and CD in terms of h, right? So the tan of theta is opposite over adjacent, which is h over d, right? So there it is again. Tan of theta is equal to h over d. Tan of theta is equal to h over d. They told us that the inverse tan of a half, tan to the minus 1 of a half, is equal to theta. Therefore, tan of theta is equal to a half. Okay? And we know that tan theta is equal to h over d. Therefore, 1/2 is equal to h over d. Multiply across, you get 2h. D is equal to 2h. D by 1, 2 by 2h is equal to d, or d is equal to 2h. H is equal to d over 2, therefore, right? And based on this, we have this from there to there is 25, and from there to there, that's h, and the whole thing is 25. Therefore, CD is equal to 25 minus this bit. Okay? So CD is equal to 25 minus h. So that there is 25 minus there, and we got h is equal to d divided by 2. Right? So that's the answers there, and hence or otherwise find h. Right? So we know we have everything here, so we'll use this thing here, because we have d and we have CD, and that's what they were talking about. We need to find the value of h. So we have 25 squared, that's a right angle there. 25 squared is equal to d squared plus CD squared. Right? And we know what CD, the CD is equal to 25 minus h, and d is equal to 2h, therefore d squared is equal to 4h squared. So I can get an equation in terms of h only and then solve for h. So we have 25 squared is equal to d squared plus cd squared. D squared is equal to 2h squared. 25 squared is equal to 2h squared, because I just figured out that d was equal to 2h, right? And we know that cd is equal to 25 minus h. So we've got cd squared, which is 25 minus h squared. So we've got 25 squared is 625. 2h squared is 4h squared. 20 square this out, so you get 20 squared first, 25 squared a second, minus h squared is plus h squared, twice the product. The product is h by minus h by 25 is minus 25h. Twice the product is minus 50h, right? So we now, and then we can rewrite that. We got 625 is equal to 4h squared plus 65 plus h squared minus 50. I'll write it out again. 625 is equal to 4h squared plus 625, taking the brackets out, plus h squared minus 50. 625s will cancel. You'll get 0 is equal to 4h squared plus the h squared gives you 5h squared minus 50h. Bring that over, you get 50h is equal to 50h is equal to 5h squared. Divide across by h, you get 50 is equal to 5h. 50 divided by 5 is equal to h, therefore h is equal to 10.